Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. So in this video class, I am going to teach you specifications of tokens. So you know what is meant by tokens. It has attribute name and optional attribute value, right? One example, if it is position, I will write it as identifier 1, ID 1. This is token. It is split the source program into small pieces called token. And specification of token, how we can specify the token. First one is alphabet. Okay, alphabet is a sequence of character or a sequence of letters, okay, that is called alphabet. It may be numeric alphabet and it is enclosed by open parenthesis and closed parenthesis. For example, if it is 1, 2, okay, so this is called as alphabet, okay, I will say this is a number and numeric alphabet. If it is A, B, this is also called as alphabet, okay. And string is a set of characters taken from the alphabet. For example, if I have A, B, this is the alphabet, and I can form a string A, B, B, A, etc. I can form many number of strings. That means sequence of characters taken from the alphabet, right? That is called string. And language is a, we can form a string and we take languages. We can form a languages by using string as well as alphabet, okay. So that is denoted by L, okay. So now prefix of string, that means removing zeros at the end. If I remove all the zeros at the end, that is called prefix of string. And suffix of string is removing zeros at the beginning, that is a suffix of 0. So prefix of 0, suffix of 0, okay. So this is the specification of tokens. And next one is regular expression. So last semester we studied what is regular expression, clear? You know what is regular expression? Regular expression, we can easily describe finite automata using a regular expression, okay. So we have few operators and that is a few things, that is union, concatenation and union, concatenation and closure, right. So union will denote it as plus, concatenation denoted as dot, and closure is denoted as star, okay. Union, concatenation and closure. So we have a precedence of regular expression. Which one has highest precedence is star has the highest precedent, second highest precedent is dot, least highest precedence is plus. That already I taught you in a previous last semester theory of computing. Next one is finite automata. Finite automata. This also I taught you in a theory of computation, but why they are keeping this also in this compiler design is, this concept is also necessary to create a parser. Next unit I am going to teach you what is parser. So this concept is also needed for a to create a parser, okay. So finite automata, you know what is finite automata? Finite automata is a machine model. It performs computation and control moves from one state to another based on some external input, right. And it has a transition diagram, transition table, etc. You just refer to last semester video, okay. So in the finite automata have two types. One is non-deterministic finite automata, and another one is deterministic finite automata. What is deterministic finite automata is, the control moves from one state to another based on external input, that is finite automata. Deterministic is, we can determine where the control is, okay. We can determine where the control is. For example, if it is state 0 and 1, and if it is A, if I ask you state 0 reads A where it is, I can determine it is 1, okay. And state B where it is, I can determine it is B. And state 1 it reads B where it is, I can determine it is 1. State 1 reads A where it is, I can determine it is 0, right. This is deterministic finite automata. And one thing you should remember, this is called DFA, because each state it should read two alphabet, A and B, not two. How many alphabet they have given? All the alphabet it should read at least one time. That is called DFA, deterministic finite automata. NFA, it is not necessary to read one time or one or more times, okay. That is called NFA. For example, 0 it reads B but it doesn't read A, so that is called non-deterministic finite automata, clear, right. And finite automata tuples, we have 5 tuples. finite automata f equal to capital Q comma sigma comma delta comma q0 comma f. Okay, or I can write it as final state. You can mention this as another state also. What is capital Q is finite set of states. Capital Q is a finite set of states. What is sigma? Finite set of input symbol. What is delta? It is a transition function. What is q0? It is a starting state. What is f? It is an accepting state. Okay, one small example. For example, q0, q1, and alphabet is alphabet sigma equal to a comma b, right? A, b, and this is called a starting state. This is an accepting state, and if this is a alphabet a comma b, this is called as finite automata, because capital Q is finite set of states. How many states are there? 2, q0 and q1. Sigma is finite set of input symbol. How many input symbol? A and b. Delta is transition function. q0, delta of q0 comma b, it goes to q0. Clear? See, q0 comma b, it goes to q0, that is transition function. q0 comma a, it goes to q1, transition function. Delta q0 is a starting state, f is an accepting state. Okay, this is a finite automata example. And transition diagram, this is a transition diagram, and transition table, you can write a transition table that I told you. Here it is a state, that is q0, q1. Here it is the input symbol a and b. q0 it reads a, goes to q1. q0 it reads b, goes to q0. q1 it reads a, does not go anywhere. q1 it read b, go to doesn't go anywhere. Okay, so here also empty. This is transition table. So this everything I taught you in the previous semester. If you have any doubt, kindly refer to the previous semester. NFA and DFA, you should know the difference between NFA and DFA. Okay, you should know the how to differentiate NFA and DFA, and you should know what is capital Q, sigma, delta, q0 and f. Clear? Okay. Now I will give you one small example for NFA, and I will separate what is DFA. Okay, so the sigma means alphabet a comma b. They are given input symbol is a comma b, finite set of input symbol is a comma b. I want to draw, and capital Q is a finite set of state. Finite set of state is q0 comma q1. Okay, and I want to draw one NFA. So you know what is starting state? q0. So starting state is marked as with the arrow q0, and what is accepting state? q1, double circle. NFA, I can write anything, A and B, this is NFA. q0 is not mandatory or not necessary. State should be read all the input at least one time. See, here q0 A is reading, B is reading, but q1 doesn't read A and B. But in DFA, that state should be read at least one time. So A it reading, B also it reading, and q1 also read A or comma B, or instead of B I can put B. The thing is, it should read A and B at least one time. This is the DFA, and this is NFA. Okay, so next video I am going to teach you regular expression. Thank you.